So let's continue with our binary search playlist. But before that, hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So the problem that we're going to solve today is minimizing the maximum distance to gas stations. Now what does the problem state? The problem states that you'll be given an array which will be containing n integers. Now these n integers will be representing the coordinates of n gas stations. Now over here n is 5. So the first gas station is at the coordinate 1. The second gas station is at the coordinate 2. The third one is at 3. The fourth one is at 4. And the fifth one is at 5. Now it is not necessary that they will be in consecutive order like 1, 2, 3, 4, 5. They can be something like 1, 13, 17, 23 as well. It is not necessary like 1, 2, 3, 4, 5, 6, 7, 8. It can be in anything like 1, 13, 100, 1000. It can be anything. But the only thing that is given to us is they will be in sorted order. Like all the coordinates will be in sorted order. So you're given the coordinates of n different gas stations. Now what is your task? Your task is to place k new gas stations. So in this example, you have to place 4 new gas stations. And in placing them, what you have to do is you have to minimize the maximum distance between any 2 gas stations. Now I can give you examples. Imagine I say that I'll place 4 new gas stations in this manner. 1, 2, 3, 4, 5. They'll stay as it is and I'll end up placing them at 6, 7, 8, 9. Now this is a way in which I can place the gas stations like the new 4 gas stations. If I do that, what will be the difference between any 2 consecutive gas stations? It's 1, it's 1, it's 1, 1, 1, 1, 1, 1, 1. Any 2 consecutive gas stations has a maximum distance of 1, can I say? Has a maximum distance of 1. So if I go ahead and place it like this, the answer will be 1. Can I do something different? Probably yes. What if I do something like this? I place 1, like the 1 will be at 1. And imagine I place it at 1.25. You can place it at decimal coordinates as well. Imagine I place 1 more at 1.5, 1 more at 1.75, and then at 2, 3, 4, and then another at 4.5 and another at 5. So I've placed 4 new coordinates, 4 new gas stations, 1 over here, 1 over here, 1 over here, and 1 over here. And the existing 5, you cannot change them. You can only determine the coordinates of the 4 gas stations that you have to place. So if I place them, the difference is 0.25, 0.25, 0.25, 0.25, 1, 1, 0.5, 0.5. What is the maximum among all? The maximum is 1. So if the maximum is 1, the answer will be 1. So you have to find out the maximum distance. So that will be 1. Okay, so for this also the answer is 1. Can I do something different? Probably yes. What if I go ahead and say 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5 and 5. Now if I try to figure out the difference between 2 consecutives, it's 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5. Each of the consecutives have a difference of 0.5. So what is the maximum? The maximum is 0.5. Can you do better? You can try out, but you cannot do better. Like I tried out over here by making sure that the difference is 0.25, but eventually the previous ones had a difference of 1. So I have to make sure that I have to place it in such a way that any 2, if I pick up any 2, the max distance has to be minimized, In this case, it is 0.5. If I place them in between of everyone, the max distance will be 0.5, and that's the minimum I can do. I cannot go anything beneath 0.5. So what you have to return is 0.5. Yes, that is what you have to return. So in questions where you have to return answers which are in the decimal formats, they might be asking you to return in a long double data type or a double data type. So these are the couple of data types that they will be asking you to return within. Like in the first example, you saw that the answer was 0.5. So you definitely cannot store it in an integer. You have to either store it in a long double or a double in order to return it, or maybe a float as well. So 0.5 was very simple. What if the answer was something like 0.6, 7, 8, 9, 1, 2, 5, 6, 7, such a big number? Now, in such cases, what they do is, they tell you note answers within 10⁻⁻⁶ of the actual answer will be accepted. What does that mean? Let me explain you. So what happens in the background whenever you submit a code? So what happens is, there is a server, right? Most of us know that there is a server. So I'm kind of talking in terms of design. Now there's something as test cases, and there's something as your code. So there's something as your code, and then there's something as the problem setter's code or the tester's code, can be anything. So what happens is, the setter's code is already run against this particular test case. It is already run against this particular test case, and it already has a output 2. Imagine it is called as output 2. So what happens when you click the run button is, your code is sent to the server, the test cases are sent to the server, and your code runs on the given test cases, and an output 1 is generated, Now this output 2 and the output 1 is compared. If the output 1 and output 2 is equal, they call it as an accepted answer. If the code, while running against the test cases on the server, ends up taking a lot of time, in that case, they'll be returning something as time limit exceeded. Like if on the server, they would have set the server that 1 second is your time limit, and your code is probably taking more than 1 second while running those test cases, it might end up returning a time limit exceeded. And if it doesn't matches, like if it is not matching, in that case, it says as a wrong answer. Now, this is what happens on the background. And this one looks very simple. Like, okay, you just need to compare. So whatever this is generating, go ahead and compare. But imagine in cases where you have to return something like long double or a float, and my program is probably printing an answer something like 0.65421678124. It's like a huge, like a long decimal, like extremely long decimal. And the setter's code, probably they would have done some optimization, probably. And they're also getting something like this, but maybe something like this. And you're getting something beyond this. Again, it can be an extremely long one. What will happen is, if you end up generating an extremely long one, the time taken will be huge, and you'll end up getting a TLE. Because if you're going to generate the exact answer in terms of long double, that might end up taking a lot of time, and you might get a time limit exceeded. So that is why the setter's code will always do some optimizations, and what they will do is, they'll probably store answers, let's say till 7 decimal places. Like 7 decimal places is what they will probably store. So this is what they would have stored, like 4 and 4. This is like 8 decimal places, for an example. Now imagine you are returning something like this, like a huge long decimal. Then you'll get a TLE. This is the reason they clearly tell you, please just return up till 6 decimal places. Do not go beyond that. Do not spend more time in calculating. So what happens is, you will kind of stop till here, because that is 6 decimal places. You will stop till there. And then what happens on the background is, they just check equal till 6 decimal places is what they will check. They don't care what is after it. You can send whatever you wish to after 6 decimal places. They do not care. If the first 6 decimal places are matching, that is it. They will call it as an accepted answer. And that is the reason why you'll always find this line whenever the answer has to be returned in a long double or a float format, because they do not want your code to run on the test cases forever. Because when we talk about double, the answer can be extremely long, and they just don't want that much of time. That is the reason you'll find this in most of the problems. So we need to think of a solution, but if I start thinking of a solution by taking such a big example at the first, I think that will be an issue. So what I'll do is, I'll try to trim down the example, and if I trim down the example and I take, let's say, 2 gas stations, one at 1 while the other one at 7, and I'm asking you to place 2 more. So what will be the optimal strategy that you'll use to place these 2 gas stations into the existing 2, such that you minimize the maximum distance? So probably one of the strategies can be, I'll say 1 and 7 are there, and I will place them at 8 and 9. So if I do that, the distance will be 6, it'll be 1, like the consecutive. and the maximum is 6. So am I somehow reducing the maximum distance between the existing gas stations? The answer is no. So will it make sense to place the new gas stations outside the extremes, like the left extreme and the right extreme of the given n gas stations? It doesn't make sense, because if I place them outside, the distance between them will still be the same. So ideally, placing anywhere to the right or to the left doesn't make sense. Where is the ideal scenario? It's placing in between, because the distance is 6 and I want to reduce this 6 and reduce the maximum. So the optimal strategy will be to place in between the given n gas stations. So that is something we have figured out. So we have 1 and we have 7. If I have to place it, and I say let's place it at 2 and 4, because I have to place 2 new gas stations, and this is the distance, this is the distance, and this is the distance. Does it make sense? We still have 3. I'll be like, no, it doesn't make sense, because you still have 3. So what is the ideal scenario if I give you like 2 gas stations and you have something like this? I'll be like, hey Striver, I have 1, 7, and I know I have to place 2 gas stations. If I place 2 gas stations, this will be one consecutive distance, this will be another, and this will be another. So there will be 3 consecutive distance that I have to make sure is minimized. Because if I just let go 1, that will be like 3 is very high. 3 is very high. I cannot let go 1, because that 1 might be very maximum and I want to minimize everyone. So I'll have to minimize 3 consecutive distances. And how much is the 3 distance? It's 6. And I have to split it into 3 equals. So that's like 2, 2, 2. So if I just split it into 3 equals of 2 and place it at 3 and place it at 5, then the distance will be 2, then the distance will be 2, and then the distance will be 2. Does make sense? So what I'll do is, if I've been given 2 gas stations, I will try to place them between them in equal sectors of length 2, so that the max distance is minimized, and the answer is 2. Got this? So this is the thought process under which we will be solving the entire problem. So let's now take this particular example where we are given 4 gas stations and you have to place 5 new gas stations in between them. We know one thing for sure, we cannot place anything to the right or anything to the left. So what we will do is we'll place 5 probably somewhere between this and this. So there are like 3 sectors, 3 sections where I have to place. Can I say, if I start thinking by taking like all the 5 at a time, that will be an issue. So what I will do is, let's quickly start off with 1. So if I take 1, where will you place? I'll be like, hey Striver, over here the distance is 12, over here the distance is 4, over here the distance is 6. Which is the maximum? 12 is the maximum. So if I have to place 1, I'll try to place somewhere in between 1 and 13, so that this 12 is reduced, because ultimately I'm trying to minimize. Got it? So what I'll do is, I'll try to place 1 between 1 and 13. Maybe I can store it where I'm placing. So what I'll do is, I know there are 3 sections, 1 section, 2 section, 3 section. So I'll say how many are placed in each of this. So this is the 0th section, 1st section, second section. 0th, 1st and 2nd. So I'm saying 1 is placed here. Perfect. 1 is placed over here. Amazing. Next is the 2nd one, when the 2nd gas station is in picture. So ideally if you have placed 1, where would have you placed it? You would have placed it at 1, 7 and 13 and then 17, 23. This is where you would have placed it, because the ultimate distance was 12. So you'll keep a distance of 6 and keep a distance of 6. This is where you'll place it, right? So after placing 1, let's look at the distance. 6, 6, 4 and 6. So apparently as of now, after placing 1, the maximum distance is 6. So you want to kind of get rid of this 6. You want to reduce it. You want to reduce the 6. So maybe I can place in either of these sectors, because I already have 1 at 7. So I can place either of this or either of this. So maybe let's go ahead and place in between. So I'll go ahead and say 1 is there, placed. Now let's come up with the 3rd gas station. So when these 2 are placed, hypothetically, if you only have to place 2, hypothetically you have to only place 2, there will be like 1, 7, 13, 17, 20 and 23, where 20 and 7 is the new one, and now the distance is 6, 6, 4, 3 and 3, right? And how did you know that the distance is 3? It's very easy. If you're placing 1 over here, that means it is broken down into 2 sectors. It is broken down into 2 sectors. And if it is broken down into 2 sectors, how much is the distance over here? Because each of the sectors will be of equal distance. It will be 23 minus 17 by the number of sectors, which is the number of placed plus 1. So it's like 6 by 2, that's 3. The difference is 3. Very simple. Over here, the same thing. 13 minus 1 by the number of placed plus 1 will be the sector. 12 by 2 is 6. 6 and 6. So you know one thing. This is 6, this is 6, this is 4, this is 3 and this is 3. So where will you place the 3? You'll try to reduce this 6 because this 6 is creating an issue. Now let's think. If I say 113 and 7 is here, this is 6 and this is 6. What will you do? Will you take this third gas station and place it maybe somewhere in between them? Will you do this? Will you do this? Will you place it somewhere like 4 or will you place it somewhere like 10? Does it make sense? Because even if you place it at 4, this will still be 6. And realize the initial configuration had 113. You are at liberty to place the first and the third gas station. You can move. You can move them anywhere. So ideally what I'll do is, instead of placing the first one at 7, which I did, I'll try to take the entire distance 12. And I know there was already one in between them. I'll have 1 more in between them, so I'll have 2 more in between them, which means I'll have to place 2, which divides it into 3 equal sectors. So 12 by 3 will be 4. So now I'll place them at a distance of 4, 4, 4. Got it? So what I'll do is I'll place them probably at 1, 5, 9. So this will be like 4, 4 and 4. So what I've done is I placed 1 more in between 1 and 13. So the number increases to 2. So the number increases to 2. So tell me one thing, if there are 2 placed in between 1 and 13, what will be every individual sector's length? It's 1 and 13. The total is 12. And if there are 2 placed, that means there are 3 sectors. So it will be like 4. The individual lengths will be 4. The individual consecutive differences will be 4. Got it? So the third one is also placed. Let's talk about the fourth one. So I know one thing. This has an individual length of 4. This has an individual length of 4. This has an individual length of 3 because 6 by 2, right? So what will you try to minimize? You'll try to minimize 4 and 4. So maybe let's take this 4 and place it here. So what I've done is I placed it here. So there will be like 2 sectors of 2 and 2 each and go at 15. Quite obvious. So the fourth one is placed. Time for the fifth one. So when I try to place fifth one, what happens is I have 130. I have 113. There is already 2 there. So between 113, there's already 2 which is at 5 and 9. But I need to place 1 more. So the distance is 4, 4, 4. How did you figure it out? Difference 12. How many placed? 2. How many sections? 3. So that's like 4. Over here. So for this, the difference is 4. For this, the difference is 4 by 2 sectors. So 2. Over here, the difference is 3. So which is the highest? The highest is here. So where will you place? Here, because you're going to reduce that highest length. So let's reduce. So can I say, I'll place it here. Done. What I've done is, I made sure I've placed 5 of the new gas stations. Once I've done that, can I figure out the equal section length between this? Yes. Let's do it. How many are there between this? I'm saying there are 3 placed between this. So it's like 1 and 13. There are 3 placed. So if there are 3 placed, there will be 4 sectors of equal length. The total difference is 12. 4 sectors means 3. So first one will be placed at 4, then 7, then 10. The distance will be 3, 3, 3, 3. Perfect. Now you have 17. I'm saying 1 is placed. So 1 is placed means 2 sectors and it will be at 15. So the difference will be 2, 2. How did you find out? 17 minus 13 by 1 place means 2 sectors. That means a difference of 2. Where's the next? 23. How many placed? 1. So if 1 you are placing, that means 2 sectors. 23 minus 17 by 2 is 3. So 3, 3 placed at 20. What I've done is, I made sure to figure out what is the distance between each consecutive and what is the max. The max that I can see is 3. How did you find out the max? You don't need to place them. 13 minus 1 by 2, 3. Each sector is of 3. Each sector is of 2. Each sector is of 3. So 3, 2, 3, which is the max? 3. That's your answer. This is the brute force. Might look tough, but when I try to write the code, it's going to be super simple. Don't worry about that. So we need to write the code. You might think it's going to be complex. No, it's not that complex. What are we keeping track of? We're kind of keeping track of how many were placed between them. And we were trying to place one by one. The first thing I'll do is I'll try to go one by one. So gas stations will start from 1 and will go till K. That's the first thing I'll do. Quite simple. What I've done is I've basically gone from 1 to K. Now I have to keep a track of how many have been placed. Maybe I can take something in like a how many array. So tell me what will be the length of this how many array. So initially it's like 1, 2, 3. There are 3 sections where you can put in the gas station. So they're like 3. And you know the indexing will go by 0 based. So initially there are 0 gas stations at every consecutive existing gas stations. So what we need to do is we need to figure out where will this first gas station go. Where will it go? I'll figure out the distance of every section. If there are any place, I will divide it. I'll try to place it at the place wherever there is maximum. So maybe I'll have to keep a track of which is the maximum value. And at the same time, I'll also have to keep a track of where is the maximum value occurring. Like in this case, it was 12 and it was occurring at the 0th. It is occurring at the 0th section. So what I need to do is, this is the first section, this is the second, this is the third. So there are like 3 sections and n was 4. So I'll have to run a loop from I equal to 0 till n minus 1, right? What is the difference? What is the initial difference if I have to ask you? The difference is very simple. Array of I plus 1 minus array of I. Again, the array is sorted, so it will be fine. So initially what happens is 13 minus 1. So this will be 12. This will be 12. But remember one thing. If there was one gas station already placed, this is actually 6. This is actually 6. So how do you figure out? You figure out how many are there. So basically, the section length will be difference by how many are placed plus 1, because if there is one placed, it will be broken down into 2 sections. It will be broken down into 2 sections. So difference by how many plus 1 placed. That is the section length of that. That's the section length of that currently. I need to figure out the maximum section length. If maximum is smaller than section length, what I'll do is, I will say maximum equal to section length and I'll say max index equal to I. Quite simple. Once this for loop ends here, once this for loop ends here, what will happen is I would have figured out where is the maximum lying and I will go ahead and place that gas station at that max index. I'll just do a plus plus. So what will happen is I'll go across and place it there. Once I have done all the placements, I have to go through every one and figure out what was the section's individual length. So that's the maximum answer. So the max answer will be -1 and I can go across every section individually. So that's again n minus 1, I plus 1, and I'll again do the same process where I'll say the section length is going to be array of I plus 1 minus array of I divided by how many were placed plus 1, because that is going to be the section length. And if that exceeds my answer, so I can do a max of max answer dot section length, and at the end of the day I can return this max answer. I can return this max answer. Quite simple. And if you do this, You'll figure out each of the individual section lengths and you can easily return them. I know the presentation was not that great on the iPad, but no issues. Let's quickly go back into the code editor. What I've done is I've written the exact same code so that it's much more readable. Initially go through all the gas stations, and I know initially everything will be -1. Make sure that you define long double, and then you find out the initial differentiation, like initial difference, and then you figure out what is the length by dividing it by how many were placed +1, and if it exceeds, you do this. And right at the end of the going through all these sections, basically you figure out wherever was the max, you just increase the counter. Once this is done, you go through every section and you figure out what's the individual section length and you figure out the max of it, because that is what you have to return. Make sure that you do the typecasting properly, otherwise you'll be getting a wrong answer. So if I go ahead and submit this will be giving me a time limit exceeded. It'll be giving you a time limit exceeded. Why? Because you're running a loop for k. So that's like k, and then internally you're running a n, and then another n to figure out the maximum. So this k into n is kind of quadratic in nature, and this is the reason why it will be giving you a time limit exceeded. So what we need to do is we need to kind of optimize this k into n. So let's quickly come back to the brute force solution. So we did see that this loop is taking k and this loop is taking n, and that is making it as a k into n. Something that I cannot avoid as of now is this one, because my entire logic depends on placing individual gas stations. Now what is this loop trying to do? This loop is trying to figure out the max length. That is what it is trying to do. Now can I probably try to optimize this one? And if I can optimize this one, my complexity can be reduced. So this is what I'll try to think of. I'll try to optimize the maximum finding mechanism. So let's quickly check if we can do that or not. So before we move on to improving the time complexity, let me quickly tell you about a data structure priority queue. In case you have seen my C++ STL lecture, you already know about it. And in case you haven't seen it, I'll just quickly give a recap. So this data structure is there on C++ STL as well as on the Java collections. So it's not a linear data structure. Internally, it is implemented using Heap data structure, but I'm just writing it on a linear fashion to explain you in a much easier way. So imagine this is a priority queue, and I ask you, okay, priority queue dot push 2, priority queue dot push 3, priority queue dot push 1. And if you do this, and after that you say priority queue dot top. So if you say dot top, this push takes logarithmic of n time complexity, this takes logarithmic of n, this takes logarithmic of n. So if you say pq dot top, what happens is you have inserted 3 elements. Now the priority queue always stores the maximum at the top. Maximum at the top. It stores in a tree fashion, but that's a completely different thing. But as of now, remember, if you say pq dot top, it will always give you 3, because 3 will be at the top. If I have to explain it in a linear fashion, it will be something like 3, 2, 1. So if you say dot top, it will give you 3. And after that, if you say pq dot top again, it will again give you 3, because it will not be removing it. And if you after that say pq dot pop, what will happen is this 3 will be gone. This 3 will be gone. After that, if you say pq dot top, it will give you 2. So this is what the data structure is. What do we need to do? We're taking big O of n in order to find out the maximum. We need to optimize it. Obviously, we don't need to optimize it to n by 2, because that's not a significant improvement. If I have to talk about improvement, because it was taking k into n and it was going towards quadratic, I need to be somewhere in the range of k. So that's going to be like, I have to reduce it to logarithmic of n or big O of 1. Obviously, I cannot find constant in I cannot find maximum in big O of 1. So that's out of question. Can I do it in logarithmic of n? Probably yes, because I know a data structure which always gives me the maximum in this pq dot top takes a big O of 1, but this pq dot push takes a logarithmic of n. So kind of in a logarithmic time, it gives me the maximum. So I know a data structure which gives me maximum in logarithmic of n. So maybe I can try implementing it. So we know that we have a data structure which gives us the maximum. So we need to start. So what I will do is, I will keep how many as we did in the first one. And we know that there are 3 sections, 0, 1, 2, and I'll keep 0, 0, 0, because initially I haven't placed any gas stations. If I ask you what is the length of the initial sections, 12 for the 0th, 4 for the first, and 6 for the second. That is something which I know. And whenever I place the first, I always take the 12, because that's the maximum. So what I will do is, I will take a priority queue. Yes, I will take a priority queue. And I'll say, first section, what is your length? He says 12. 12, 0, go into the priority queue. Next section, what is your length? 4. 4, 1, go into the priority queue. 1 is the index of that section. What is the next? 6, 2. So what I've done is, in the priority queue, I'm storing it in pairs. And the pairs is storing the length of the section and the index of the section. Done. Let's quickly now start our algorithm. I say first, gas station, where will you place it? You're like, I have 12, I have 6, I have 4. I have to place it such that this 12 goes down. I need to minimize. So I'm like, okay, you have to place there, go ahead and place it. So you're like 12, 0. I have to place it at 12. How many are there at 12? It's like 0. At 0th index, there's like 0 placed. What is the difference? 12. So what will be the section length? 12 by 1. 12 by 1. And that's 12. So I can place it. So I've got 12, 0. I can place it there. I'll go ahead and place it there. So I placed it there. So if I place it there, what is the length? 12. I placed 1, which means that it will be broken down into 2 sections. That means now this 12, 0 will become 6, 0. The length of this one is now 6, 6, 6. So what I'll do is, I'll go ahead and say 6, 0. I'll go ahead and say 6, 0. Remember one thing, the priority queue will store it like 6, 2 will be at the first. Why? Because if the first one is matching, it differentiates it on the second factor. So 6, 2 will be at the front. The first gas station is placed. I'll go for the second. For the second, I say 6, 2 is a perfect choice. I'm like 6, 2 is a perfect choice. What that means is, on the second section is where I'll place. Go ahead and place it on the second section. 1 incremented. And if you increment 1, previously the length was 6. You have placed 1. So broken down into 2, it will be of a length 3. So 3, section 2. Perfect. Let's do for the next, which is the third gas station. For the third, it's 6, 0 for sure. No doubt in that. So I'm saying the 0th section. What is the length of the 0th section? 12. How many are placed? Now? You're placing one more. How many are placed? 12 by 3. 4. Isn't it? Because you got this section which was previously length 6 because there was 1. Now you are saying I am placing one more. So 12 by 3, that's 4. So the new length will be 4, 0. Perfect. The new length will be 4, 0. So you are storing the current length and the section. And over here it stores how many? So which one will be at the top? Obviously 4, 1 will be at the top because priority queue stores that. So you'll just take 4, 1 out. For the fourth, you'll take 4, 1 out. And what will you do? You will say, this will go here. And if it goes here, what's the length? 4 by 2, so it's 2. So you'll place like 2, 1. The section is 1, so that's placed. Perfect. What's the next? The fifth. For the fifth, 4, 0 comes in. So you say 3, and this time what happens? Yes, the initial length is 12. How many have you placed? 3. 4 sections, so 3. So now you say 3, 0 is what goes inside the priority queue. By the way, 3, 2 will be at the top. Done. Placed 5. You have placed 5. And you know the 0th section is of 3, the first section is of 2, and the second section is of 3. And you need the maximum. You need the maximum value because that's your answer. You again just call a pq.top. You just call a pq.top and you get 3, 2. You get 3, 2. So the second section has a value 3. And that's the answer. The first section also has a value 3, but you just need the one value. So 3 is the answer, and that is what you will return. Quite simple. So I hope you have understood the optimized solution. Now the point to note over here is, whenever you take something out, so initially you took 12, 0 out. This is the main one. Like 0, the section index is the main one because this is where you place, and on the placement, the new section length is defined and that is what you insert. Anyways, I'll quickly show you in the code editor because I don't want to write on the iPad. It's going to be super messy. So let's quickly go back into the code editor. What I'll do is I'll quickly have the priority queue, and that will be pair of long double and int. Make sure it's a long double, otherwise you'll be having an issue. And I'll quickly remove this. I'll remove this as well. And I will be returning pq.top because the top dot first is what will be my maximum. But before that, what do we need to do? Initially in the priority queue, I'll have to insert all the sections. So let's quickly insert all the sections. It's going to be pq.push. And it'll be like array of I plus 1 minus array of I, comma I. Done. So what I've done is I've made sure that the priority queue already contains the section length and the index. And how many is already assigned as 0. Over here, what I will do is, I know one thing. I can write as auto. And the top element that I'll get is pq.top. So once I've got the top element, make sure you pop it out as well. Otherwise, it will stay in the priority queue. After that, you just need the section index. So maybe you can write section index tp.second. Do you need the length? The length is of no use. I go to how many and I say at this section index we have the maximum. So please go ahead and increase it. So what I've done is I've taken this particular gas station and I've made sure that it is under this section index. Now what I can say is, what is the initial? Yes, what is the initial difference? The initial difference is nothing but array of wherever the section index is, right? That is what this will be the initial difference. What will be the new section length? Maybe I can again take long double and I can say new section length, and that will be initial difference by long double again. Please make sure you don't do any typecasting errors, otherwise it will be an issue. Long double of how many of section index plus 1, that is what will be the new section length. Once you've done this, you can go to priority queue and say this is your new section length, comma your section index, because that's what will be the section index. Once you have done this, you can simply go ahead and return pq.top first, and that will be running. So if I quickly go ahead and run this off, I think this will be running fine. It does. I'll quickly go ahead and submit this as well. What is the time complexity? It's a big O of n log n, because priority queue.push takes log n. It's a k plus a push log n. So it's an n log n plus k log n solution, and thereby it is accepted because you have omitted the quadratic stuff. So if I go into depth now and if I write down the time complexity, that's an n log n plus k log n. Again, it's like n minus 1, but I've written it as n log n. What is the space complexity? How many am I keeping in the priority queue every time? N minus 1, because if I have like 4 gas stations, I'm keeping always 3 sections. It's like an n minus 1. So this is the time complexity and the space complexity of the better solution, not the most optimal solution. Now, in an interview, if I was the interviewer, I'll be happy with it. I'm done with this if you are giving me the solution. But a lot of interviewers might not be happy, and they might be asking you to reduce the space complexity. And this is where the optimal solution comes in. So time for the optimal solution. The question is asking you to minimize the max distance between any 2 consecutive gas stations. Whenever there is something like minimum and maximum, I think we have done a lot of problems for you to understand that this is something which can be solved using binary search, because you're trying to minimize something which is the maximum. So we can apply binary search, and we have done similar problems previously. But in this problem, the catch is the answer is in long double. So we definitely cannot do something. The generic binary search has something like while low lesser than equal to high, and this is okay if it is an integer. And we also have something like low equal to mid plus 1 and high equal to mid minus 1. Now the generic binary search operates in this pattern where we have done all the problems. Yes, we have done all the problems till now where we had just taken low lesser than equal to high. Nothing like lesser high or equal to, no. All the problems we have done with this, and every problem we have taken mid plus 1 and mid minus 1. None of the problems we have taken mid or mid minus 1, nothing. All of the problems we have solved using this particular pattern. But over here, the answer is in long double. So all of the pattern will, like, each of the statements will not work. This will not work, this will not work, this will not work. Why? Plus 1 is definitely not going to work because you're kind of missing out on a lot of things. So what will you do? Will you do like plus 0.1? Will you do like plus 0.0001? Will you do like plus 0.0 something like this? No, you can't do something like that because you have to find a proper answer. Even if you do this, you also might end up missing a lot of things, because if you do this, that might end up taking a lot of time, as I explained in the initial part of the videos, because your answer might be 5, 6, 7, 1, 2, a long double, and it might end up running for millions and millions of times, because it might be meeting at some like 89th decimal place. To do that, it will look for millions of operations. So you cannot write something like this. So the pattern slightly changes. Yes, the pattern slightly changes. All the double or long double binary search problems will always have a pattern like. What happens is, instead of comparing high lesser than, like low lesser than equal to high, or doing something like this, you look at the problem statement. The problem statement was asking you to make sure that the answer is matching somewhere around 10 to the power minus, like it should match till 6 decimal places. So what you will do is, you will say high minus low if the differentiation like between them is exceeding this 10 to the power minus 6. If they are differentiated at somewhere beyond 6 decimal places, I'm okay. If my low and high are standing with first 6 decimal places matching, I'm done and dusted. So this is what will happen to the condition. And instead of doing low equal to mid plus 1, you will always do low equal to mid, and you will always do high equal to mid. You will not be reducing it. And this will make sure that if you start, like in this example, you had 1 and 5. If your low is standing at 1 and your high is standing at 5, it will make sure right at the end, the low and high are standing in the correct place. Like I just took an example. So in all the, like usually you will not find them in interviews, but I'm just teaching you just in case they ask you. This is a very rare problem in an interview. You might not find it. Remember the pattern, high minus low, greater than 10 to the power minus 6. If they're asking you 7 decimal, it will be minus 7. And the low will be mid and high will be mid. Now let's come back to solving the problem. We know how to solve binary search double problems as of now. What was I doing in all the other binary search problems? I was kind of writing a while loop, and then I was doing some check, using some check functions, and using the check function, I was determining whether low will go to mid plus 1 or maybe our high will go to mid minus 1. This is what I was doing, right? This is what most of the binary search problems I did. I tried to figure out this check function, and on the basis of that, I either eliminated the left half or I either eliminated the right half. That is what I did. Now the different thing that I'm doing over here is mid plus 1 goes and mid minus 1 goes. But I have to figure out on what will I check, So throughout the binary search, we always checked on answers. The same thing we'll do over here. So we need to apply binary search. So if you remember, in all our existing binary search problems, the first thing we figured out is the range in which the answer can lie. So can I say the answer can lie between 0 to somewhere? Why am I saying 0? Imagine I'm giving you a test case where all the n gas stations are at the coordinate 1. There are 4 gas stations and they're at the coordinate 1. And I'm asking you to place 4 more. You'll again go and place it at 1. I haven't said that you cannot place it at the same coordinates. You can. So ideally, the distance between any 2 will be 0, right? So the answer can be somewhere from 1, okay? And where can the answer be till? The answer can be till. I can place it outside, but will it make sense? No. What am I looking to optimize? I'm looking to optimize the max distance already being there. I need to reduce it. It cannot be beyond that. So if you remember with this example as well, where is the example? With this example as well, there was 12, 4, 6. The answer cannot be beyond 12, right? It cannot be 13. Like if you decide to place it at 100, it can be, but why will you? You're looking to minimize. So it can be somewhere under 12 if you try doing it properly. So what I can say is, I'll try to look for all the maximums. And the maximum that I find is like all the consecutive difference, and the maximum that I find is 1. So it'll be like from 0 to 1. I know one thing for sure is the answer is going to be between 0 and 1. Now my question comes, how do I check? And in all the problems, what I did was I started from 0, then I went to 1, then I went to 2. I did a linear search. And over here, it's like 10 to the power minus 6. So if I have to do a linear search, I'll have to do it something like this. For like maybe the distance is 0. That is, again, everything will be in long double, 1. And the distance plus equal to 10 to the power minus 6. Every time I just increase it by 10 to the power minus 6, minus 6, minus 6, minus 6. I keep on checking. Got it? So I know that the answer lies between 0 and 1. But over here, if I have to do a linear search, I'll have to write it something like for distance equal to 0. I go until 1. And every time, I cannot do plus plus. I have to increase it by plus 10 to the power minus 6. Because it's a long decimal thing. So if I have to do a linear search, I have to go like 0. Next one will be 0.000 something. Then it will be like 0.0002. It will be like 0.0003. Then it will be like 0.0004. And so on. I will have to go by increasing it at the 6th decimal place. Got it? We cannot go like 0 and then 1 and then 2 because it's a matter of double. So first, I have to check for 0 and then I have to check for 0.0001. But in order to understand, what I'll do is I'll just check for 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7 and so on till 1. Just to understand. So tell me one thing. If I keep a distance of 0, how many gas stations will I be able to place? Let's see. So if I try to keep a distance of 0, I'll have to place infinite gas stations in order to make sure the distance doesn't exceed 0. Why? Because I'll have to place something at 1, 1, 1, 1, 1, 1 and I cannot go beyond this. It's not possible. It's not possible. Because if I just do 1.1 as well, the distance becomes 0.1. The difference, like if I try to place one gas station at 1 and another at 1.1, the distance still becomes a difference of 0.1. And I want to keep my answer as 0. I want to keep my answer as 0. So what I see is, it's not possible. It's not possible by just placing 4 gas stations. I cannot. Actually, I cannot. So not possible. Okay. So I'm like, it's not possible to place 4 gas stations or to keep a distance of 0. Simple as that. So this is not possible. Let's see if 0.1 is possible. If I try to keep a distance of 0.1, can I place it at 0.5? I cannot place it at 0.5. Why? Because if I place it at 1.5, the distance will be 0.5 already. And I want to keep a distance of 0.1. I want to keep a distance of 0.1. So I'm like, no, Raj, we can't do that. We can't do that. So I'm like, okay, where can I place it? I'm like, I can straight away place it at 1.1. Nothing beyond that, because the moment I place it at 1.2 as well, the difference will be 0.2 and that will be my answer, because I'm looking for max. But I want to make sure that the answer doesn't cross 0.1. So 1.2 is not possible. 1.2, then 1.3 I have to place, then I have to place 1.4, then I have to place 1.5. Well, I'm taking a lot of gas stations. I don't have that many. So I cannot keep an answer of 0.1. Because in order to keep an answer of 0.1, I need a lot more gas stations. And I only have 4 gas stations. So not possible. 0.2, for the same reason, not possible. 0.3, for the same reason, not possible. 0.4, for the same reason, not possible. Because you have to keep like 1.4. And then maybe at 1.8, you'll place 1. And then you have to go. Maybe the next will be 2.4 and then 2. You have to go. So at the end, it's like 2.8 and then 3.4, 3.8. So you're already crossing, because the difference you see 0.4, 0.4, 0.2. In order to keep a 0.4 distance, you need way more than 4 gas stations. So 0.4 is also not possible. I hope you're understanding why 0.4 is not possible. Because I cannot go and place it at 0.5. The distance will be 0.5. I want to keep a distance of 0.4 at maximum, not more than that. So 1.4, 1.8. I need 2 here, 2 here, 2 here. So it'll be more than 4 gas stations. So not possible. 0.5. If I keep a distance of 0.5, it's going to be point. And I'm saying, if I keep a distance of 0.5, I'm exactly requiring 4 gas stations. So it's possible. It's possible. And if it is possible, what am I looking for? I'm looking for a minimum answer. So what you can do is, you can eliminate the right half and probably look on the left side. 0.4 is eliminated, but there will be 0.4444, 0.45 something. Got it now? What I'm meaning to say. So since it is long distance, we have to look at the left portion. So I'll probably go at the left and look. So again, if you take 0.6 also, it's still going to be possible. If you 0.6, 0.6, 0.6 is also possible. You're keeping a distance of 0.6, 0.4, like the distance is still 0.6. It's not beyond 0.6. Even if you take 0.6, you can still do it in a 4. Even if you take anything more than 0.6, you can still do it in 4 or lesser. So that is why anything on the right, if the distance is large, and I'm able to do it in lesser number of gas stations, that is okay. But if I'm requiring a lot of gas stations, that's not, I don't have that liberty. So something I know for sure is, if I'm requiring the number of gas stations required is greater than K, that's not possible. I need to increase the distance. So what I'll do is, I'll eliminate the left half and I'll go there. And if it is the other way, if it is lesser, that means that answer is, I'll have to just go to the left half. Because even with 0.7, 0.8, it's possible. I need to go on this one. So you go high equal to mid. That's what you do in binary search. Got it? So how do you figure out how many gas stations you actually need? So let me take an example. If I had something like 0.4, it was like I was placing 1 and then 1.4 and then 1.8 and then 2. So I was able to place 2 gas stations. And then it was like 2.4, 2.8. How did I figure out that I was able to place 2 gas stations between this? It's very simple. You say 2 minus 1, that's 2 minus 1 by 0.4. You get something like 2 point something. But you don't take the decimal part, you just say 2. Because I can take 2. Got it? So now you might have a question. Straight away, it was easy for 0.5 because you did like 2 minus 1, the difference is 1. And you said there can be 2 placed as like 0.4, 0.4. And for 1, I'll kind of reduce it because I want to maintain an answer of 0.4, which is okay. But for 0.5 straight away, like this was like 2 elements placed. But if I take 0.5 and I know the distance is 1 and I say 1 by 0.5, so saying we can place 2. That is wrong because if I go 1, I can only place like 1 by a distance of 0.5 and then it will go to 2. I cannot place 2. That is wrong. The absolute division will be wrong. This is where you will do if 1, like the difference of the section is properly divisible by the number that you're looking for. That means you can place 1 lesser. In this case, it was okay because 2 minus 1 was 1. 1 by 0.4 was something like 2 point something. So that point went in over here. So that was okay. But this is like properly divisible. So it's not possible. Got it? So this is where you have to be careful. So I hope you have understood everything. I did not do a lot of dry runs because it contains long double. And to do a dry run on double values, it's very, very tough. Trust me on that. So I'm assuming that you have been watching the entire playlist so you can easily catch up with it. So let's quickly write down the binary search code. So the low will be 0 and the high will be the maximum of consecutive differences. We can easily find it out. And what you can do is high minus low will be greater than the 6 decimal places. That is what you write. And make sure everything is in long double, otherwise you will be having an issue. Perfect. Done. What is the next thing? Figure out the count of gas stations required to maintain this mid distance. Just figure that out. And that can be called as count. And remember, if this count is greater than the number given to you, what does that mean? That means it's not possible. If it exceeds that, it's not possible. And if it's not possible, you got to increase the distance because this distance is not possible. It's just too low. For that, you need a bunch of gas stations. Otherwise, it's possible. And maybe we need to eliminate the right half and look for a smaller value. So you eliminate, because you have to minimize, you eliminate the right half. Remember one thing, the last possible one was when high was mid. When high was this, so maybe you can store answer equal to high. Something like this. And at the end, you can return the answer or high. over here, the concept of opposite polarity will not work that I've been teaching you, because this is not mid minus 1 or mid plus 1. Last one was high equal to mid when it was possible. So high is probably storing the last answer. So that's why you return high, or you can also return answer. That is your choice. This is how it will look like. What about count of gas stations? I don't want to write it here because it doesn't matter if it's C++ or Java. The code is going to be pretty much similar because we just iterate over the array. So what I'll do is I'll quickly jump into the code editor now. So let's quickly jump into the code editor. As you can see, we are given the array and the k. Initially, what am I doing? I'm taking the low and high as 0. Long double, please make sure. And then I figure out the high by figuring out the difference of consecutives. So you just have n minus 1 sections, so you can do that. And then what I do is I do the normal binary search for doubles. That is according to the question. If you see in the question, I think, yeah, this is where they're stating it. So I do it accordingly. And after that, I find out the mid. And I call a function which tells me how many gas stations are required in order to maintain this particular distance mid. And then if it is a lot more, I need to increase the distance. This is not possible. Else I decrease it, and that is what I return. Now this is what we have to focus. Let's go to the function. Number of gas stations required. I have to keep a distance, and this is the array. Initially, I say that number of gas stations required count is 0. And I have n minus 1 sections, so we start from 1. And in order to find out the difference of the section, it's array of I minus array of I minus 1. By distance. What is distance? That has been given to you. 0.4, 0.5, can be anything. And this is the number that I require in between. So if it is 0.4, if you remember, let's quickly go back into the iPad. If it was like 1 to 2 and the distance was 1. 1 by 0.4 is 2 point something, right? So this is what I'm checking. If it is exact division, pure mathematics, you can do it on pen and paper. Then I have to reduce 1y. Because if it is 1 by 0.5, that will be 2. And I cannot take 2, I have to reduce minus 1 from it. I have to reduce 1. For 0.4, it is 2.5, I'll take the integer which is 2, that's okay. So I'm taking an integer. If the exact division matches, I decrease the number in between. And depending on that, I add it. And eventually, I'll have the total numbers if I add up all the sections. And that is what I return. Let's quickly go ahead and run this off and see if it is running fine. It should be. Yeah, it does. And now let's quickly submit this off. Same pattern of binary search. Writing the binary search and having a check. And according to the check, eliminating the right or left. Just because it is in terms of double or long double, we cannot do minus 1 because that will eliminate a lot of numbers. So this is the standard procedure of doing binary search on anything which has long double. I don't expect this question to be asked, but just in case it is, that is why I'm teaching you. And I know it was tough because all the 3 solutions are tough. It's not that one of the solutions is easy. All of them are tough. And this is probably one of the hardest questions if you ask me to rank in terms of interview questions when it comes to binary search. So do not worry about that. Let's talk about the time complexity. So let's talk about the time complexity. Big O of n, logarithmic of the range length is the time taken for binary search and an n. So n logarithmic of n plus n. Are we using any extra space? No. This is where we optimize from the priority queue solution. And if the interviewer doesn't agree on that, tell him to. Anyways, I hope you have understood this. I know it has been a long video and it took me nearly 3 hours to record because I was retaking most of the times because I wanted it to be precise and to the point. And I hope you have understood everything. And if you are still watching, you can hear my voice. It's almost done. So please do consider giving us a like. And if you're new to our channel, do consider subscribing to us. And with this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye-bye. Take care.
Whenever your heart is broken.